In section 4.1, you multiplied a matrix by a number called a scalar. That was one number outside of the matrix, and you multiplied every number inside of the matrix by it. In this section, you're going to be multiplying two matrices together. The setup for multiplying matrices is different from the setup for adding matrices. When you added and subtracted two matrices, the dimensions had to be the same. This is not the case when you're multiplying matrices. When you write the dimensions of a matrix, you must list the number of rows by the number of columns. To multiply two matrices together, the row, and actually this should say the column of the first matrix must match the rows of the second matrix. Okay, so in other words, if you write the dimensions of the first matrix next to the dimensions of the second matrix and circle the two middle numbers, if they are the same, you can multiply the two matrices together. If two matrices can be multiplied together, we say their product is defined. If they cannot be multiplied together, we say their product is not defined. Okay, so let's look at a couple of examples here. I'm going to take the columns of the first and the rows of the second. So remember, this is the row, this is the column. We're going to circle the two inside numbers. Those are the same. Okay, so now the new matrix is going to be the dimensions of the two outside numbers. So this is going to be a 2 by 2. Have to be the same here. Next one. We're going to circle the two inside numbers, and this is not defined. Okay, now we're going to do the next one. We circle the two inside numbers. Once we match them up, we cross them off, and our dimensions are the two outside numbers, so 3 by 3. We need to know what size our new matrix is in order to do the multiplication, and you'll see why in just a few minutes. Now, here's an example of how you multiply matrices. And we're going to actually just go ahead, if you want to refer back to that, that's fine. We're just actually going to jump right in and multiply two matrices on the next page. So we're going to do A, B if possible. So we know we can't, this is a 2 rows and 3 columns. This is 3 rows and 2 columns, so 3 by 2. Now we know we can't add those together because they're not the exact same dimension. But what we do to check if we can multiply is we check those two inside numbers. They match. So the dimensions of our product matrix will be the two outside numbers, so 2 by 2. Okay, so we write the matrices next to each other, multiply the row 1 by column 1, and add the products together and continue. Now what I'm going to have you do, since we have a 2 by 2, I'm going to have you draw two rows and 2 columns. The next thing I'm going to have you do, this is a row, so this is row 1, row 1. I'm going to have you write row 2, row 2. Now we're going to do the columns. This is column 1, this is column 1. This is column 2, this is column 2. The reason why I'm having you do this to start with is because it'll help you figure out which row and which column you need to take from each matrix. Okay, so now let's write the matrices out here. So in matrix multiplication, it's commutative. So A times B is not the same. So AB does not equal BA. So it's important that we put them in the order that we're asked to multiply them. So let's go 0, 4, 9, -3, 3, 2. That's matrix A. And we're going to multiply it by matrix B, which is 5, 1, -2, 7, Now, as long as you can multiply and add, you can do matrix multiplication. Okay, so if I need to figure out what goes in row 1, column 1. So the rows I'm going to take for this one. So I go this way on that. And I need the columns. Well, let's write it this way. I need the columns from the second one. So sometimes I suggest people use paper clips. And if you need some, just let me know. What I'm going to do, the first matrix, we always take the rows. The second matrix, we always take the columns. Okay, now all I do is I take 0 times 5, and that's going to give me 0. Multiply the first one times the first one, the second one times the second one, and I add them together, so plus -8, and the third one times the third one, so plus 54. I'm going to put some braces or brackets around here. Okay, so then we'll add them up together here. So we would add 0 plus -8 plus 54, and that's going to give us 46. Okay, so that's row 1, column 1. Now I'm going to go to row 1, column 2. So I stay in row 1 here, switch this to column 2, and now I do 0 times 1, which is 0, 4 times 7, which is 28, always adding in between, and 9 times 0, which is 0. So if I add these together, that's going to give me 28. Okay, now I want to go down to row 2. So I'm going to slide this down to row 2. This location says row 2, column 1. So I'm going to slide this over here. And now we're doing -3 times 5, so that's -15, plus 3 times -2, which is -6, plus 2 times 12. Or sorry, 2 times 6, which gives you 12. Okay, so that's going to be -21 plus 12, which is going to give me a 9 for row 2, column 1. Now I'm going to do row 2, column 2. So sliding this over here, I do -3 times 1, which gives me -3, 3 times 7, which is 21, and 2 times 0. And when I add all those together, I end up with 18. All right, now matrix multiplication is not commutative. And that means that order matters. CA is not the same as AC. Okay, now this is one matrix that people get confused with quite a bit. This is not equal to taking matrix C and doing 11 squared, -1 squared, 12 squared, and 0 squared. What it means is we need to take the matrix C, and I'm going to have to move it up here just so you can see this part of it. We're going to do 11, -1, 12, 0, and we multiply it by itself. So 11, -1, 12, 0. Okay, now we're going to find the dimensions of our new matrix. So this is a 2 by 2. This is a 2 by 2. We're going to circle the two inside numbers, and we notice that we can multiply them together. So I'm going to cross this off, and my new matrix is a 2 by 2. So I have 2 rows and 2 columns. I'm going to do the same thing again. I'm going to say, okay, these blanks are in row 1. These blanks are in row 2. This is column 1. This is column 2. And remember, I take the rows of the first one, the columns of the second one. So I'm going to move this paper clip to, I want to get row 1, column 1. Slide it over a little bit like that. All right, so I'm doing 11 times 11, which is 121. And I'm doing -1 times, is that a 12? Yep, Negative 1 times 12, which is negative 11. No, negative 12, sorry. All right, and then we're going to add those together. So 2 rows, 2 columns, and that's going to be 109. And now I'm going to go row 1, column 2. So 11 times negative 1 is negative 11. And then we have negative 1 times, yeah, that's a negative 1. That's a problem sometimes with paper clips. You can't see the whole number. So negative 1 times negative 1 which is going to give me, oh, wait a second here. We have, let me line these up a little better. Okay, so we have 11 times negative 1 to get that, and negative 1 times 0. So that's going to be plus 0 there. All right, so that's going to give us negative 11 over here. And now I want row 2, column 1. So here's row 2 and column 1. So 12 times 11 is going to give me 132. Oops. And then I do, so the first one times the first one, second one times the second one. So that's going to be 0 times 12 is going to give me 0. And that will give me, adding those together, 132. Now I want row 2, column 2. So I'll stay row 2 here, go to column 2 here. And I have 12 times negative 1, so that's negative 12. And then I have 0 times 0. So first one times first one, add those together. Second times second, add them together. And that's going to give me 0. So I'm left with this one is negative 12. And there's my matrix. And now you have a couple you try it's to do.